Okay, hello people. Hello everyone. My name is Alex Martinez and welcome back to Mr. M's Academy. Today what we're going to be talking about is a power product of exponents. Now, if you don't know what that is, that's okay. That's why we're here. If you have any questions on what a power is or what a base is or what anything like that is, check out my previous videos. I go over all that. But what we're going to be learning, what we're going to be talking about today mainly is the power product property. Is What is that? It is when you're multiplying powers with the same bases. When you multiply powers with the same bases, all you're doing essentially is adding the exponents. Now I wrote down two columns here. One is called the numbers column, one is called the variable columns. We're going to first go through three different scenarios where you can use this definition, and then we're going to go through a few examples, and that's going to be it. Now, first example is something that has the same base, like 4 to the fourth times 4 to the fifth. Which one is the base here? The base is going to be the big number right here. This represents the base, and the blues are going to represent the exponents. Now, the power product property says, what do we do when when we're multiplying stuff that has the same base? What do we do with the exponents? Well, we keep the base the same, and we take these exponents and we add them. So this becomes 4 to the power of 4 plus 5. And what is 4 plus 5? If you don't know what that is, you need more help. It is 9. So we get 4 to the ninth power, people. We get 4 to the ninth power. That's it. Now, with this product rule applies to variables as well. Now, let's look at something that has variables. We have this x to the m times x to the n. We have the same base. Again, these two are the bases. We have the same bases and different exponents. What do we do with these exponents? All we do is we take them and we add them. So we get x to the m plus n. And that's it. Since we don't know what any of those three variables are, we can just stop there and say the answer is x to the power of m plus n. Now let's look at a different scenario where we're still using the power product rule. We're still using this rule, but it's going to look a little different because we're going to be given a problem that looks like this. It's 3 to the second power, all powered to the third. Now, what do we do when we have something like this? What do we do? Okay, when we have something inside of parentheses with an exponent, our exponent here is 2, and then we have parentheses and an exponent outside as well, all we need to do with those two exponents is multiply them. So you take those two exponents and you multiply them. So we end up getting the base of 3. The base always stays the same in all these examples. The base is 3, and you take the exponents and you multiply them. So we're going to multiply 2 times 3. And then what is 2 times 3? Again, if you can't answer that, Lord help us, it's 6. So we get 3 to the 6th powers. I'm just kidding, you guys. So we get 3 to the 6th power. Now we can do the same thing when we have variables as well. Let's look at something like, I don't know, let's look at x to the m, and then that's raised to the power of n. Well, again, we have an exponent inside the parentheses and an exponent outside. The power rule says we can take those two exponents and we can multiply them. So we get x to the m times n. And that's it. We can stop there because, again, we don't know what any of those three variables are, so we can just stop there. And then scenario number 3. Let's say we have something that looks just a little bit different. Let's say we have 3 times 4 all to the power of 3. And again, sorry, my exponents are going to be blue in this case. Now, what do we do when we have something like this? Here's what you got to do. You have two things now inside the parentheses. So this exponent applies to now two things. Notice that every single time we have something with a parentheses, it applies to everything inside the parentheses. So we can rewrite 3 times 4 to the power of 3 as 3 to the power of 3 times 4 to the power of 3. We can actually just stop there. So we get 3 to the third power times 4 to the third power. That's all you got to remember. Now let's consider us having like a variable. Let's say we have a variable like, I don't know, a and b. And it's being multiplied, or sorry, it's being powered to the n. So again, there's two things inside the parentheses. So this n has to be applied to both things inside the parentheses. So let's apply it to the first letter we see. We see an a, so it's going to be a to the nth power. And we see a b, so it's going to be b to the nth power as well. So we get a to the n and b to the n. Let's see example number 1. Let's take something such as, I don't know, ooh, this one. This one looks fun. Negative 2 over 3 to the power of, I don't know, 3. Let's continue doing our exponent same color. I'm sorry, I'm bad with color coding. And then we got negative 2 to the third to the 5th power. Now don't freak out, it's a fraction, but we got this. What does the power product rule say? If we have the same bases, which we do, these are the same bases, they're equal, then all we need to do is take these exponents, this 3 and this 5, and we just gotta add these two. So what does this look like? We keep the base the same, negative 2 over 3, and then what do we do with the exponents? We add them. So we take 3, we take 5, and what's 3 plus 5? Again, you should know that, it's going to be 8. So we get negative 2 over 3 to the 8th power. Now let's do one that has like x to the 3rd power times x to the 4th power. Now again, the first thing you should always check, do we have the same base? Yep, we're good. So we're good to go. We can actually just end up, we can do the next step, which is just looking at the exponents and adding them up. What is x to the 3 plus 4? Well, what's 3 plus 4? 7. So we get x to the 7th is the answer here. Now I would ask if there's any questions, but you guys can't answer me, so I'm going to move on. Let's look at example number 3. Let's consider something that actually has the second type of scenario that I wanted to go over. So example number 3 would be something that looks like 4 to the, let's do 4 to the 3rd power, and then let's do a 5 in there. Okay, so we have 4 to the 3rd all to the 5th power. So remember, the product property lets us do this. If we have an exponent inside the parentheses and an exponent outside, what we can do with those two is simply multiply them. So let's take 4, let's take the base 4, leave it like that, and let's just multiply the exponent. So we got 3 times 5. And then what is 3 times 5? It is going to be 15. So we got 4 to the 15th power. That's it for that one. Now let's do another example. I want to do, ooh, this one looks fun. Let's do 5 to the xy, okay, 5xy, all to the 3rd power. So this one is going to cover scenario number 3, where you have a bunch of things inside of parentheses, and they're all being powered to something. In this case, the power, the exponent is 3. So what do you do here? You take this 3, and you have to apply it to each thing inside the parentheses. In this case, there's 3 things inside the parentheses. So apply it to all 3. So we got 5 to the 3rd, x to the 3rd, and you can guess this, z to the 3rd. And then we can't really do much more with this because we don't know what x and z are, but we do know what 5 to the 3rd is. 5 to the 3rd is, well, 5 times 5 is 25. Okay, it's 125. And then we got x to the 3rd and z to the 3rd. That's all we can do. That's it. Now, very last example, because it wouldn't be me if I didn't do like a fraction, because we live for fractions here. So let's do like 1/2 xy all to the, I don't know, like 3rd power. Okay, looks fun. So again, don't freak out. How many things are there in the parentheses? Well, I see 1, 2, 3. So we know this 3, this exponent has to be applied to every single thing inside the parentheses. That is the rules. You need to follow the rules. So we got 1/2 to the what? 1/2 to the 3rd power. We got x to the 3rd power. Oops, sorry. X to the 3rd power and y to the 3rd power. So I've finished that part. I've applied 3 to every single thing inside the parentheses. Now x I can't do anything with, y I can't do anything with, but 1/2 I can. So what's 1/2 to the third power? Well, let me do it on the side over here. So let's do like some little side work right here. So what the question is, what's 1/3 to the, what's 1/2 to the third power? Well, recall, here's how you expand this. You take 1/2, you take the base, and you multiply it by itself how many times? 3 times. Why 3? Because the exponent is 3. So we take 1/2, multiply it by itself 3 times. So we got, when we're multiplying fractions, just multiply straight across. So we got 1 times 1 times 1. Again, what's 1 times 1 times? It's just 1. And then 2 times 2 is 4. 4 times 2 is 8. So the answer is 1/8. So our final answer over here is going to be 1/8, x to the third, and y to the third. And that's going to be it. Alright guys, thanks for watching. I hope you enjoyed the video. If you have any questions, please leave them in the comments below. Subscribe if you feel like it. Like the video if you learned something. Thank you and have a good day.